Hello, this is the 2023 Calculator Applications District Guide. I will be showing you how to answer every single word and geometry problem on the test. Let's begin. Number 6. Calculate the positive square root of the sum of 637 and 677.7. You add them up and take the square root of them, like the problem says. Calculate the reciprocal of the sum of these two numbers, add them together, power them to -1. That's the definition of a reciprocal. And you get 1.15 times 10 power to -3. Number 8, just put it right in your calculator. Easy enough. Get 2.19. Number 9, figure out the radius with the circumference. The circumference, or the radius, is the circumference over 2 and over pi. And then the area is r squared times pi. If you do that, then you'll get an area of 166. Trapezoid. The area of a trapezoid is equal to the average of these two sides times the height. So as you can see, these two sides are added up and divided by 2 to take the average. And then it's multiplied by height to get an area of 1.81 times 10 powered to 3. 16 was the area of a rug that is 8 feet by 12 feet, and it wants the answer in inches squared. Well, convert both of these to inches and multiply them together, and you get 1.38 times 10 power to 4. A group of 435 people is 34.5% women. How many men are there? Well, the percentage of men and percentage of women must add up to 100%. So the percentage of men is equal to 100% minus 34.5%, as shown here. Convert it to proportions, and then that value is multiplied by the total 435 people, get a value that's pretty much right next to 285. 18. Carrie buys a dress marked at that much, including the bill or sales tax. How much change does she receive with $50? Well, she pays with $50. The total cost of the dress is going to be the original price multiplied by 1 plus the tax, because the sales tax is 0.08125 times 35.75, and that's added on to 35.75. You subtract that from 50, and you get $11.35. Okay, 19, right triangle, it gives you the area. Basically, what we're looking for is the area of a triangle is the height times the width. So the height in this scenario is 0.0612, and the width is cotangent of this angle multiplied by this side, because cotangent is opposite over adjacent. Cotangent is 1 over tangent, and you multiply that by the other side, and then you divide by 2 because it's a triangle, and you get 0.00166. Make sure if you put that in EQ solver, that will make things way easier. Just make sure you're in degree mode. And if you do that, you get a degree of 48.4. Another triangle area problem. You need to figure out this side, so use Pythagorean theorem to figure it out. 28.5 squared minus 24.4 squared. Take square root of that, you get this side right here. Area of triangle is width times height, so that side times 24.4 and divided by 2 because it's a triangle. And you get an area of 180. 26, a gallon of gas costs that much. Several months later, it costs that much. What is the percent increase? Percent increase is new minus original over original. So your new gas price minus your original price over your original price. And then you have to multiply that by 100 to turn it into a percent. Okay, 27. The most distant spacecraft is 14.5 billion miles from Earth. How long does it take something traveling at 186,000 miles per hour to reach Earth? So, or that reach the Voyager. So the total miles that the Voyager is away is 14.5 billion, or 14.5 times 10 power to 9. And that the amount of time it would take an object to traveling at 186,000 miles per hour is the distance over the speed, is the time. Then you divide by 60, convert from seconds to minutes. Divide by 60, convert from minutes to hours. 28. The Great Pyramid of Giza, Egypt, was originally 480 feet tall. Today is 454 feet tall. It was completed 4,600 years ago. What is the erosion rate? Well, first off, find the amount that has eroded in feet, which is 27, as shown here. Convert that 27 feet to millimeters using side tools, and then divide that a bunch of millimeters by 4,600 to get 1.8 millimeters per year. There are two SDs because at the end you are dividing by something with two SDs, as you can see here. There's only two significant digits. These zeros do not count as significant digits, and you get 1.8 millimeters per year. Okay, the volume of this cube, given this AB side, for this you are going to want to use three-dimensional Pythagorean theorem. It's basically like two-dimensional one where you have one side squared plus another side squared, but now you add in a third side squared. So each one of these sides are going to be equal to our side x that we're looking for. So 2.97 is equal to square root of x squared plus x squared plus x squared. And if you cube x, the x value you get, you will get the volume. And that volume is 5.04. 30. The total surface area of this cylinder is given. Okay. First off, part of the surface area of that cylinder is these two circles on the top and bottom, which are r squared times pi. And there's two of them, so the diameter over 2 is your radius. That's squared, that's times multiplied by pi, and there are two circles. Then you have your lateral surface area. So the lateral surface area is the circumference of the circle, which is diameter times pi, as seen here, multiplied by the height, which is unknown. And all that has to be equal to 0.0458. And you get an x value of 0.148 when you do that. Okay, the half-life of tritium is 12.3 years. What percent of tritium sample decays in 1 day? Well, basically you can think of it as the decaying is 1/2 power to time over 12.3 years. Because if 12.3 years pass, the tritium would decay in half, as shown here. However, this also needs to be converted into days because there's only 1 day. This t is 1 day, so you have to convert years to days by dividing by 365.25. So if you do that, you get the amount left, or the percentage of the tritium left. So to find out how much it decays, you have to subtract that number from 1, and then multiply by 100 to get a percent value, as you can see here. The deck of the Columbus ship is 17 meters by 5.36 meters, was the average space per person. 27 crew members are on deck. Multiply the two values together to get the area in meters squared. Then use side tools. Go to apps, scroll. If you want to use side tools, then you should go to apps, scroll up, side tools, unit converter, and then area. And then you put in your area, gotten, and convert it to what it's asking for is feet squared. And once you have that value, you divide it by 27 because there are 27 crew members equally sharing the space. 38. Hannah can bike from Paradise, Texas to Eden, Texas in that long, and she drives in a shorter amount of time. What's the percent increase in velocity? Well, the velocity is the same thing as distance over time. So let's just say our distance is 1 mile. The distance doesn't matter in this case because because the distance is the same for both routes. So you have your faster car, which will be the one that takes less time. So 1 over that time, 3 hours and 36 minutes over 60 to convert to hours, subtracted from the slower time, which is using the same logic, 1 mile or 1 distance worth over the time, and then you divide it by the original. This entire thing is basically new minus original over original. And if you do that and multiply by 100 again, you'll get 397% increase, which has 3 SDs because this is the lowest number of SDs at 3 here. Okay, 39. Plug this right into triangle and pair circ. Plug in all 3 sides and get circumscribed radius. If you do that, you get 51.8. 40. Okay, use law of sines to figure out this angle x here. Law of sines, this angle, or sine of this angle, over that, times that, and sine -1, or sine inverse of the entire thing. If you do that, you get this angle. So this angle right here is 180 degrees, or pi, minus x, which in this case will get you 1.75. 46. Roof pitch is the vertical rise in inches divided by a 12-inch horizontal run. The square shingles will cover that much roof. Roof on a 1,200-foot house was planned to have a pitch of 4 and required 33 squares of shingles. How many shingles are needed for a 3,700 square feet house with a higher pitch? This is one of the harder problems on the test for sure. What you got to realize is that the square, basically, you got to figure out the relation between the hypotenuse that the shingles will be on and the horizontal aspect that the house areas are based off of. And to do that, you do Pythagorean theorem of the base given to you, 12 inches squared, plus the vertical rise for the distance, which is given to pitch of 5.5 on the new one, and you divide it by the pitch on the old one. And that basically means there are going to be this many more shingles per square foot of the house. Kind of hard to explain, but just imagine this hypotenuse has more for its or is longer than this one, so there's more roof to cover. And then you have it also just gives you a larger house to cover, so you multiply those proportions, new over original, and then you multiply it by the 33 shingles needed originally. And if you do that, you have to round up because you can't have less shingles than you need. And if you do that, you get 51 shingles. 47. Also, this one is less hard, but very, very annoying. Basically, it's a linear regression problem like every 47 is, but you need to convert all these to inches and ounces since they are looking for an inch amount for a certain ounce. So fortunately, and since weight is based on a side length cubed, all of these lengths have to be cubed. So the first one is easy. It gives you inches, it gives you ounces. Put in 4.3 into the L1, and then 3 into L2. Then you have to convert 68 millimeters to inches, and then cube that value, put it into L1, and then convert 23 grams to pounds, and then multiply by 16 to get ounces. You'll be wanting to use side tools for all of these. Apps, scroll up, get the side tools, then go to length. Or you can calculate the area beforehand, plug it in. Actually, no, I don't think they have that for millimeters. But anyway, do the same thing for this. They give you it in inches. Got to convert 10 grams to ounces. And then use EQ Solver for at what length cubed will be equal to 3.5. You go to Stat, calculate linear regression, store regression in Y1, and then you go to EQ Solver and figure out when Y1 is equal to 3.5, and then you have to cube root that value to get the side length because we cubed everything going into X. 48, plug it right into EQ Solver, easy enough. Make sure the value you get is positive. If you get a negative value, do a guess that is larger than your previous guess. 49. This one is pretty darn long. You got a lot to figure out. First off, you got to figure out what this height value is here. So to do that, you need to do Pythagorean theorem of this 40 squared minus half of this diameter squared to get a height around 37.3. Once you have that, you can calculate the volume of the object in terms of this side x here. We know it's equal to 30,500, so what you got to do is, this is the Pythagorean theorem I showed, you got to do the the radius squared, which is 28.8 over 2, and then you divide by 2 since it's only a semicircle, and you do have to multiply by pi, and then multiply by x to get the volume of this semi-cylinder in a way. And then you have to figure out this volume up here, which is the area of this triangle, base times height over 2, times the unknown side x, as shown here. And all that is equal to 30,500. And once you have that side x, you can now do a three-dimensional Pythagorean theorem to figure out the length of AB. So AB travels 37.3 units down, so 33.7 or 37.3 squared, travels 14.4 or 28.8 over 2 meters that way, so that's shown here. And it also travels x distance that way, so that is shown here. And if you do that, you'll get the side of AB, which is 53.4. Okay, 50, a bit of an interesting one here. This is going to be a 3D shoelace problem, where we're going to use the 3D shoelace program to make things easier on ourselves. You will need to go to Stat Edit, and we're going to be marking each of these points, assuming that this height over here was 1. So in this case, it's 0 units that way, 0 units that way, but 1/2 of the distance up. So you'd plug this into L1, this into L2, this into L3. Then the next point is here. The full distance to the right, no distance that way, and no distance up. L1, L2, L3. And then you do the same thing for the other point. Half the distance that way, half the distance in, and a full distance up. And if you do that, you go to polygon size, put in 3 because there are 3 sides, and then you go to 3D shoelace, you'll get 0.4677. And then you will have to convert it back into this how it would be with this 1.46. Since area is side squared, you got to multiply that value by 1.46 squared. And if you do that, you get 0.997. Calculate the slope of the function to sine of x over pi at x equals 15. Just do it. Go to math, derivative, d over dx, put in the equation, make sure you're in radian mode, and do it, put in x equals 15. Okay, 57. 57 is always a hard one. An excavator can scoop a volume V of the earth in one scoop. The energy consumed is given by this value. What should the scoop volume be to remove a larger volume of earth if desired to minimize the total energy consumed? So since the volume of the earth is always constant, what you're really looking for is what is the minimum amount of energy per cubic or per volume in a way. So in that case, you have to do the derivative of this energy function, but since the energy cost per volume requires you to divide by volume, you do the energy at a given volume, divide it by that volume, and figure out when that value reaches its minimum, which is when the derivative is equal to 0. And this EV here is this equation right here. And if you do that, you will find that V is equal to 2.92. 58. These two matrices are multiplied. Find M of 3. Matrices multiplied by this. These three variables at the top flip 90 degrees and multiply by their corresponding numbers there. So for M3, we'll be taking the third part down here, flipping it 90 degrees, and then multiplying their corresponding numbers. -4 times -6 plus 12 times 5 plus 12 times 5 is 144. 59, solids of revolution. We have a good program for 59s like this. The upper bound is the equation y is equal to 4, and it's also bounded by the equation 3x squared is given here. So fortunately, since they're at the intersection, we can do OXOR no input, use that program, and the line number must be -3, and then you do the y equals volume to get a value of 209. 60. A plus b over a is equal to a over b, and square and rectangle. This, as it turns out, is the definition of the golden ratio. You could potentially just do the math in your head, assign b to some value like 1, and then solve for a in this case. However, you should also be able to recognize that this is the golden ratio, and the definition of the golden ratio is square root of 5 plus 1 over 2. Or that is the value of the golden ratio. If you do that, you get 1.62. 61. A speeder travels at 45 miles per hour, passes an idle police car. After 3 seconds, the police car accelerates at a constant rate. They catch up after 11 seconds. What was the acceleration? Now, first off, we got to figure out the speed of the car in feet per second. So take your speed in miles per hour, divide by 15, multiply by 22 to get feet per second. Now, once you have that, you got to figure out how far ahead the speeder is before the idle police car starts to accelerate, which is 66 times 3 seconds, so 198. And then that car also travels 11 seconds at 66 feet per second. And that value is going to be equal to the distance the car travels, which is going to be equal to 1/2 acceleration times time squared. That's something you can learn in physics if you want, or possibly in calculus if you want to prove it and whatnot. But yes, if you put this in EQ solver, solve for x, you will get 15.3. 62, this is the 62 under or overflow problem. In this case, it is an extremely rare occurrence, so it is an underflow. Their number is 0.5, and your exponent is 1 million. You do that, you get this value right here. 63, this is your kinematics problem. In this case, you're given initial velocity of 900 feet per second, release angle of 33 degrees, and it can be implied that the change in y is 0. So the kinematics 2D, y v theta, there is no change in y, the velocity is 900 feet per second, and theta is 33 degrees. You'll get delta x, that is around this value right here. Then you do kinematics 2D symmetric, given the delta x and the velocity, because now we got a new target angle, or a new target distance with this value minus 55. And then the velocity is still the same. If you do that, you get 32.8 degrees. Okay, 64. We're going to use a similar trick to the one we used over here on 50, where you should graph the lines where you could assume a is 1, so you graph the lines 1 minus x and 1/3 plus 1/6 x. Find out the intersection, and then you stat edit with all the points in mind. So 0, 1, 4/7, 3/7, and 1, 1/2. Then you will use the shoelace program. You can go to Program, Polygon, 3 sides, and Shoelace. And then once you have that, yeah, you don't use triangle pair circ. You use shoelace. So once you have that, since area is based on side squared, you got to take the square root of the actual area, 2.13, over your predicted area if A was 1. And if you do that, you get a value of A of 3.86. 65 now. Circle and rectangle. First off, you got to figure out what this side of the rectangle is. You know that the two areas are equal, so radius squared times pi is equal to side times length. You'll get an x value that's around a little over 100. And then once you have that, you subtract that value from, or you subtract 39.1 from that value, because this is a kite that's formed. These two angles are right angles, and the radius of the circle is always the same. Therefore, that forces these two sides to be the same. And this side is equal to this side is equal to this entire length minus the radius here. And if you do that, you get a value of 72.9. All right, that will be all. Hope you enjoyed. If you have any questions or need any clarifications, leave a comment and I'll hopefully answer them. All right, see you later.